All right, so if I'm looking at 6.1 and I want to go ahead and do that practice piece, a line that intersects two other lines is called a transversal. That's this right here, this line right here. Identifying relationships, think of a statement, the segment in the diagram as part of a line. Which line or planes contains point B and appear to fit the description? So here's CD is right there. And I want to contain B that is parallel to CD. So I'm going to say AB. Perpendicular to CD. Well, perpendicular to CD is going to be making a 90-degree angle. So at the back side there, so I could say CB. Askew, but it includes B. So I'm going to say skew would be back over here, BF. And parallel to CDH is going to be BAE, plane BAE. All right, scooching down. Parallel and perpendicular lines mark the diagram. Use the markings in the diagram. Pair parallel lines. Well, here's my little arrows, right? So I can say that MK is parallel to LQ. No, LS. LS. Name a pair of perpendicular lines. Well, here's my little marking right here. It goes from this line and this line. So PN is perpendicular to PQ. Is PN parallel to KM? PN is this one. Is it parallel to KM? KM is this one. No, they intersect. And PN and KM, are they perpendicular? Well, no, not at 90-degree intersection. Not at and not at a 90-degree intersection. All right. Diagram here. I want corresponding, identify all pair of angles given the type. So corresponding. So I'm going to start with 1. Angle 1 and angle 5. Angle 3 and angle 7 because they're in the same location. Angle 2 and angle 6. Angle 4 and angle 8. Alternate interior means they go diagonal from one another. So angle 4 and angle 5. Angle 3 and angle 6. Alternate exterior, that's going to be these guys. So angles 2 and angle 7. Angle 1 and angle 8. Consecutive interior, let's erase over here. Consecutive interior, so that would be these guys. So angle 3 and angle 5. Angle 4 and angle 6. 1 and 8. What are 1 and 8? Let's see. I have 1 and 8. Well, straight from my perspective, I would say they are alternate exterior angles. They're saying they're corresponding, so I could say that angle 1 corresponds with angle 5. And then down below, we have some angle relationship. So looking at the angle relationships, 5 and 1. 5 is here, 1 is here. They are corresponding angles. 10 and 13. Here's 10 and here's 13. They're right next to each other. Same side interior, so same side interior angles. Or you could call it CIA, consecutive interior. 8 and 13. That would be these two. They're also SSIA or CIA. 11 and 1. Here's 11, here's 1. Those are alternate exterior angles. 3 and 9. Here's 3 and 9. alternate interior angles, and 8 and 4. Here's 8 and 4. So 4 and 8. Those are going to be corresponding angles. All right, so then the next piece here, we're going to go to the next page. On this, we know alternate interior, alternate exterior corresponding. We also know vertical. Okay, and those are all going to end up being congruent when I have parallel lines. Okay, so this is where now we're going to have parallel lines. So if angle 4 is 118, find all the rest of them. So angle 4 is 118. Well, if that's 118, 2 is also 118. And if 2 is 118, alternate interior, 8 is also going to be 118. And then vertical angle, 6 is also going to be 118. So then the opposites of those, or those pairing up with those, so for instance 1, that's going to be 180 minus 118. So that's going to end up being minus 118. That's going to give me 2. That's going to give me a 7. Minus 1 is 6. So it's going to be 62. So the rest of these are going to be 62 degrees. So I know we're going to do a little bit of repetition here, but corresponding angles are going to be same location. So like upper right, they are going to be congruent. Angle pairs that are going to be corresponding would be like angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8. Alternate interior, that's going to be diagonal between the two parallel lines. Okay, alternate diagonal from each other, so like 3 and 6, angle 4 and angle 5. Those are also going to be congruent. Alternate exterior angles, that's going to be the outside ones. They're diagonal outside two parallel lines. So like angle 1 and angle 8, angle 2 and angle 7. They also are going to be congruent when I have parallel lines. Consecutive interior angles. So that's going to be in a row, same side, and a row in between two parallel lines. So in this case, it's going to be like angle 3 and angle 5, angle 4 and angle 6. Now, the beauty of this is these guys are not going to be congruent. They're going to be supplementary. They're going to make a linear pair. So they're going to make supplementary, I should say. They're not going to make a straight line because they're like here, right? However, they're going to add up to 180. So angle 3 plus angle 5 equal 180. You could also say angle 4 plus angle 6 equals 180. Then we have vertical angles. Vertical angles does not matter if you have parallel lines or not. They're just going to be across from each other. So like this angle and this angle. And they are going to be congruent. Across from each other with intersecting lines. Okay, so up here, if I look at my little diagram, it's going to be like angle 1 and angle 4, angle 3 and angle 2, angle 5 and angle 8, angle 6 and angle 7. We're going to use these later on for some definitions or some reasons for our proofs. All right, so here I have a couple things. This is very similar to that very first one we did, but before we get there, let's go ahead and like reiterate this again. 1 and 2 right in here. Those are going to be same side interior angles. They add up to 180. These guys are alternate interior angles. They are congruent. These guys are corresponding angles. They are congruent. Alternate exterior angles. They are congruent. All right, so now here we have angle 2, angle 3, etc. So if angle 1 is 125, well then angle 7 is 125. Angle 3 then is going to be 125. So this is, and this is. So angle 5 is 125. Okay, so those are all 125. So now I need to find out what 2 is. Well, 2 is right here, right? So that's going to end up being 180 minus 125. So this is 180 minus 125 degrees, which is, in fact, so 180 minus 125 is 55. So it's going to be 55 degrees. So this is 55, this is 55, and this is 55. We're going to use that same concept as we go over here to when I say that 7 is x. So let's erase, erase, erase. All right, so now let's starting out, I'm going to say that angle 7 is x. Well, if angle 7 is x degrees, angle 1 is also x degrees. And so is angle 3. And if 3 is x degrees, then 5 is also x degrees. However, now I need to find the rest of them, right? So the rest of them are similar to this. It's going to be 180 minus x. But I don't know what x is. So no matter what x is, I'm going to subtract it from 180. And that's going to be my answer. So each one of these, I'm just going to write 180 minus x. Done. I don't have to find any extra values. Not y. There are no y's. It's just 180 minus x. All right. Then I want you to look at some of these pictures and I want you to do some calculations. So first of all, I want you to understand if you see kind of a zigzag, that's if these legs, I should say, these legs are parallel, you actually have alternate interior angles. These guys are going to be congruent. If I can see kind of an F where they're parallel here, this would be your transversal. So extend your lines. This guy and this guy, those are going to be corresponding angles. They're going to be congruent. If I can see that I have like a C, this is your transversal. This is going to be like an X and a Y, and together X plus Y equals 180. They're supplementary. So when I'm looking at different figures, whether it be just two lines parallel or if I have them enclosed like these figures, keep in mind, here I do have kind of like that F. So I can say that this 5y is equal to that 110. And so we can divide by 5, y is equal to 22. So we know this is 110, but we know y is 22. Then I can find what x is as well, because I know that these two together make 180. So I could say 4x plus 110 equals 180. And we can solve for 4x minus 110 minus 110 equals 70, and divide by 4. I think it's 17.5. I'm not sure. Double check my math. The next one underneath it again, if I look at this, I can kind of see a backwards Z, to be quite honest. I see kind of a backwards Z, but those aren't parallel, so that's not going to help me. I know these guys are parallel, so I know that these two, this is also going to be 90. If these are parallel, this would be like a transversal, so it's actually like a Z this way. Yeah. So let me undo real quick. Let's see if we can see that Z. If you can see that this is parallel and this is parallel, kind of have a crossing right here. It looks like a Z, right? So this guy is going to be equal to this guy, alternate interior angles. So 36 is equal to 2y. So y is equal to 18. So if we know that this is 36, and together they have to equal 90, so we can say 36 plus 8x minus 10 equals 90. So 8x plus 26 equals 90, minus 26 on both sides. 8x is equal to 4, be 8, be 64. X is equal to 8. All right, then we have this guy down here. A couple of different things I have. These guys are parallel, cut by a transversal. So I know if this is 50, this is 50. So together we know this is 90. And we know that these are parallel, so that's got to be 90. If these are parallel, I can call this my transversal. So if this is 50, this is 50. And if that's 90, this is 90, right? All right. Let's look at some of these others. Oh, here I kind of have a weird F because here's my two like lines and there's my transversal. So I know that this is congruent to this. But I could also say, wait, this is actually like a C. So I know 85 plus y is going to equal 180 and solve it. I can then do that backwards F right here and say that 3x is equal to 78. And I can divide by 3 on each one. Y equals 95. And over here, x is equal to 26. That should be enough to get you going for the assignment, and then we'll do some more of these later on.